Alright, welcome to the Chapter 5 video. This is going to introduce inequalities, and we're going to go through a lot of different sections, but actually we'll start with 5-1 through 5-3 all in the same video. So in your assignment it said to watch 5-1, but actually it's only just one video covering all three sections. So please take all of these notes together, because all three of these sections combined are really just one topic, and it's not actually very difficult compared to what we've been doing before. So 5-1 through 5-3 is going to be all about solving inequalities. So first vocab, what is an inequality? An inequality, all it is it's just like an equation, except instead of an equal sign in the middle between the left and right sides, you have an inequality symbol. So there's four different inequality possibilities. We've got greater than or equal to, less than and equal to, and less than. Notice these two in the middle, they have a little bar underneath. That means or equal to. So if it's this one or this one, it's both an equation and an inequality, because the two sides could be equal to each other, or the one side could be bigger than the other side. If you're just looking at the greater than or the less than, then it's not an equality, it's only an inequality where one side has to be bigger than the other side. So when you're solving these kind of inequalities, you're trying to isolate a variable just like when you're solving an equation. And you can still add or subtract or multiply or divide on both sides of the equation to simplify it. You can also still follow PEMDAS on one side by itself or the other side by itself to distribute, combine like terms, get all your pieces together, all that kind of stuff. The only exception, really, that makes inequalities different than equations is the following. When you multiply or divide by a negative number, you have to flip the inequality. So what used to be greater than became less than, and what used to be a less than sign becomes a greater than sign. So you'll flip these two between each other, and you'll flip these two between each other. And again, you only do that when multiplying or dividing by a negative number. So this is likely something you might have covered last year in pre-algebra, but if not, it's something to memorize. And I'm going to explain real quick why it makes sense. So if you're comparing, say here's a number line, and you're comparing two sides of the equation. Here's 0, here's some number a, and some number b. So if we have that b is bigger than a, which we do based on where I've drawn them, b is larger than a, if you subtract the same amount from both a and b, they'll just shift. A will shift this way a little bit, and b will shift this way a little bit. But clearly this value is still bigger than this value. Okay? However, if you multiply or divide by a negative number, you change from being positive to negative. So a would jump over here to become a negative a, and b would jump over here to become a negative b. But because b started off larger, when you change the sign, it's now a bigger negative number. But when you're looking at the absolute scale of things, what's bigger and what's smaller, a smaller negative number, a, is larger than a big negative number, b. So because we switched both a and b to be negative, a is now bigger than b, whereas before b was bigger than a. And that's why you have to change the inequality sign. When you multiply or divide, you're changing from positive to negative, and a small negative number is still bigger than a big negative number. So if that was confusing, you could think of it as a memorized thing, but for myself, instead of memorizing, I like to try to understand why it makes sense. Okay, so what are our problem-solving tips here? When you have a multi-step inequality, you'll do it just the same way as a multi-step equation. Undo stuff in the reverse PEMDAS order. So first add or subtract to both sides, get your variables all combined together on one side, and then multiply or divide. Okay, and we're going to graph our solutions. So when it's just an equation, you might plot something on a number line. With an inequality, you're going to plot all the solutions that satisfy it, which is typically just a shaded line. Okay, so if you have a less than symbol or a greater than symbol, then you're going to use an open circle, for example right here or right here, because that means the endpoint is not included. So if I said, here, let's look at this first one right here. This looks about like maybe negative 6.5, and I want things that are larger. So I might say x is larger than negative 6.5. So this would be the graph that corresponds with x is greater than negative 6.5. Not equal to, though, because this is an open circle. Okay, right here, that's about negative 5.5. I can say x is greater than or equal to negative 5.5. Solid circle means I'm including that point as part of my solution. which would be the equals part, and then everything greater than that to the right is because of the greater than sign. Two more. This is about negative 2.5. So I can say x is less than negative 2.5. Because I'm doing less than, because I'm shading to the left, all values smaller than this value, and it's a less than sign with no line underneath it, because I'm not including the circle. And the very last one here, x is less than or equal to, because it's a solid circle, and this value is about negative 3.5. Okay, so if I'm shading to the left, it's x is less than. If I'm shading to the right, it's x is greater than. If I have a solid circle here and here, it's because I have the line underneath for the equals part. If I have an open circle here and here, it's just a less than or greater than with no line underneath. So for completeness, those are the two possibilities. Okay, we're going to do a couple of examples to show how to start with an inequality and work through it, and then all of our solutions will be graphed like this. First example, solve and plot the solution. So we have 5x plus 3 is greater than 2x minus 8. So certain values of x will make this true, and certain values of x will make this false. So we have to figure out which values of x will satisfy this inequality. So we want to follow, we'll simplify if possible. There's nothing to simplify here or here. So follow the golden rule by combining like terms and adding or subtracting to both sides. So I want to get all the x's together. So minus 2x, minus 2x, cancel. While I'm at it, I want to move the 3 over here. So minus 3, minus 3. 5x minus 2x is 3x. I have a greater than sign. And negative 8 minus 3 is negative 11. Cross those out. Then I can divide by 3. Divide by 3. Because I'm dividing a positive number, there's no funny business. The inequality stays the same. Negative 11 thirds. So x has to be larger than negative 11 thirds. And if I pick any number larger than negative 11 thirds, this inequality will be true. This side really will be larger than this side. If I pick exactly negative 11 thirds, these two sides will be equal. And if I pick anything outside of that range, then it will be false because this side will actually be larger even though it's supposed to be smaller. So to plot this solution, wow, why does it keep doing this? Don't show again. Okay, so to plot the solution, you want to label 0. Then you want to label your key point here, which is negative 11 thirds. And then maybe with a different color or with a pen or something like that, you can plot your solution. So we want to do an open circle because we're not including the endpoint, and x is greater than, which means we're shading all these values this way. And so you want to just make like a real thick arrow showing the direction and the shading. And then an open circle here. Clear open circle. Okay, moving right along to the second problem. Same thing, solve and plot the solution. So there's two things I could do. I could start by dividing by 3, but since 3 doesn't go evenly into a 7, I'm going to opt to distribute and just simplify the left-hand side. So 3 times 4 is 12, minus 3 times x is 3x, less than or equal to 7. Note that if 7 and 3 would have, if 3 would have gone evenly into 7, I probably would have divided first. But since it didn't, I didn't want to deal with fractions. So now we're solving for x, so minus 12, cancel. Negative 3x is less than or equal to 7 minus 12, negative 5. Okay, divide both sides by negative 3. Okay, those cancel. Now I divided by a negative, so I need to flip this inequality. It was less than or equal to. I change it into greater than or equal to. And negative cancel, so I have here 5 thirds. So again, we plot the number line. You always want to put in a 0, and then whatever your key point is, 5 thirds. I'll change colors so that we can see the solution. Greater than or equal to. So here I'm going to use a solid circle because of the equals to, and then greater than means I'm going to shade everything to the right. Okay, so to recap, we want to solve this system of, or solve the single inequality the same way we would solve an equation, just making sure that we change the direction of the inequality if we multiply or divide by a negative, and then plot your solution with either an open circle or a closed circle based on whether or not that point itself is included or excluded. Alrighty, see you in class.